I don't want to give anyone like a false sense of, I wouldn't say hope, but I don't want you to blame yourselves when it doesn't work out the way it's supposed to. Let's put it that way, right? We should all have hope. But, so these are real data, which is why they're not in the file. These are data from a student I worked with when I was on their dissertation committee many years ago at one of my previous jobs. This is an actual clinical psychologist whose research was dealing with people with severe mental illness in the context of a psychiatric rehabilitation center. So this is actually a longitudinal study where they're looking at how patients progress as they get treatment in the center. So time 1 was whenever they were admitted, and then times 2 and 3 were at 6 months intervals. So there were 6 different subscales that were completed for each patient. And since this, we have about 151 people, and each of the subscales had like dozens and dozens of items in it. And because this person needed to graduate, I was like, fine, you can add up your subscales and we'll work with the 6. I made a concession on that because it wasn't going to happen otherwise. So we are using subscales as if they are indicators in this example. That's one limitation. So the constructs that are being measured are some good things: social competence, interest, and personal neatness, and then some not so good things: psychoticism, motor retardation, and irritability. So in order to make these things all go in the same way, that more means a better outcome for the patient, I multiplied the negative ones by -1. So then more is going in the same direction for both positive and negative. We initially examined fit of 1-factor versus 2-factor models given the valence of the scales, but the 2-factor model did not help, so we went with the 1-factor model and work with that here. So this person, what they wanted to do is a growth model, an analysis of individual change with these individuals in whatever this latent trait is that these 6 things are coming together with. I'm going to go with psychological well-being. Can we do that? Is that generic enough? Client goodness. Any psych people want to contribute to this? Client goodness. All right, teacher goodness, client goodness. It's all good. Instructor goodness. That's what I'm trying for. So I named these things in a way that I could keep track of because all of these words sound the same to me, pretty much. So I have variable 1, variable 2, variable 3, and so forth. So I have lowercase v and then the number with respect to which indicator it was, and then uppercase T with respect to which time it was. So this is what's known as a wide format data set, where it's still 1 row per person, and all of the outcomes are in separate columns. So given 3 occasions by 6 measures, each person has 18 variables that's going into this analysis. So this is not a multiple group model. It can't be a multiple group model or it would be wrong, because we have to allow a correlation between how people were at time 1 and how they are at time 2 and how they are at time 3. Dependency, another way to say it. So we're using MLR because these are, we're assuming normal distribution, but they're not going to be. So we're going to hedge our bets with that. And the configural invariance model looks different than what we had before. So in one model statement, I have everything, because this is not a multiple group model, it's a longitudinal invariance model. Visually, it would look like, get to the picture, it would look like this picture with 3 factors instead, and each has 6 items. That's what it would look like. That's what we're setting up here. So I'm not creative, we've established that. My factor is called time 1. Client goodness at time 1. I only have 8 characters anyway. You can't be that creative with 8 characters. And the second occasion is called time 2 and time 3. So I am estimating all 18 factor loadings. There are no constraints yet that say they have to be the same over time. I am estimating all 18 intercepts, no constraints. All 18 error variants, no constraints. And because there's no constraints, I have to identify each of these 3 factors separately, the same as what I would have to do in any multi-factor analysis. So I have all 3 factor variances fixed to 1, all 3 factor means fixed to 0, and then here's the part that explicitly makes this different than a multiple group model. Up to here, they're the same. But this is what makes it different. We are allowing two different layers of covariance. We're allowing a layer at the structural level that all the factors get to be correlated with each other. And by the way, when you see this, a list of things with and then a list of things, that means all possible pairwise combinations. You don't have to write out every unique combination, so that saves you some typing. It's also a default in M+, I think. And for continuous outcomes, or when you're doing IRT models using limited information, you can also do this. I am allowing covariances for the same item over time. So what you said for item 1 gets to be related to what you said for item 1 the next time and the next time, because there's probably something specific about item 1. So that's a default that everyone's like, yeah, just go ahead and put those in there, it's fine. So they're just going to sit there the whole time. Okay, with me so far? How did we do? Well, let's see. Chi-square is significant, so our model is significantly worse than perfect. Expected. What about RMSEA? 0.099. What do we think of that? Thumbs up or thumbs down? Yeah, down. 0.1 is not good enough by anyone's standards. Definitely not less than 0.05. How about CFI? Like halfway up, like that's in the right direction. TLI, not quite. SR-MR even is unhappy. That one is usually happy. So this person was trying to graduate in the summer, and trying to get a better fitting model was like all of June. Okay, I worked with them repeatedly, and we couldn't get anything better. I'm like, you know what, fine, just go, all right? I know you got a postdoc waiting, let's just get you done. So we're gonna make it work. Here is a plot of the item loadings for all 6 indicators across the 3 occasions. So this foreshadows how this is going to fall apart. One of these things is not like the other. Item 1, right, has a very different pattern than the others. Item 5 also looks a little bit different. So we shall see if those impressions are confirmed. Here's the initial solution. At this stage, all 3 factor means are 0. All 3 factor variances are 1. So can we talk about change over time using this model in any way, shape, or form? We cannot. They're not on the same scale. It's like we standardized with an occasion. We can't make any comparisons yet. So we'll start with our first stage, metric. So to do this, I have added labels to the end of the loading lines, where it's the same labels in all 3 lines to make them all the same. What else did I do? Let me zoom it in. We'll play Where's Waldo, code style. Yeah, this part. That also what I did. Let me get both of them highlighted at the same time. Yep. Factor variance at time 2 and 3 is now being estimated, both of them. Because once we constrain the loadings across all 3 factors, we can estimate the factor variance for the non-reference factors. So time 1 is my reference at this point. Time 1 is going to give me the metric of this model. Survey says, by the way, the spreadsheets that I use to do all of this are available online. Does it fit worse than the configural model? Yep. All right, we got to figure out why. And according to all of the fit, yeah, nothing is happy with this model at this point. Model modification indices. Now this is a little bit tricky to decipher on your first try. Again, I am limiting the possibilities to just the things that are relevant, just the things that are responses to the loading constraints that I just placed. I'm eliminating all the other stuff. So the first one, for instance, by statements, those are loadings, right? That's what it's telling you about. time 1 by variable 1 at time 1. Like, wait, that's already a thing. Variable 1 is loading on time 1 already. Why does it want me to do another one? Should I have 2 loadings? What is it telling me?
It has additional variance that wants to load onto time 1 or something?
Yeah, it wants to have its own time 1 loading. It doesn't want to share with time 2 and 3. So once we have 3 groups, how many possible differences are there for each parameter between the 3 groups? Among the 3 groups, I should say. I could have time 1 and time 2, time 1 and time 3, or time 2 and time 3. So every single parameter could differ in 3 ways. So item 1 wants to be separate from the loadings at time 2 and time 3. We don't know yet about the other 2. Likewise, item 5 also wants to have a different loading at time 1, according to this, and item 6 wants a different loading at time 3. We would usually start with the one that is the strongest and start there. So the same trick in terms of giving it an alternative label. I added a lowercase a here because I couldn't add a 1. Alternative, I think, is what I was going with for that naming structure. And then I left the other ones all the same. Of course, that's a typo. There we go. Survey says, 2 different tests might be relevant. Are we headed in the right direction? So by letting item 1 at time 1 have a different loading, did we improve the model? Yes, we did. And what about, is it good enough yet? Does the partial metric model fit worse than configural? Nope. So good enough. However, we only have 150 people. And this is not a super complex model, but it's complex relative to the number of people. What do you think about our power to detect differences here? Good or like... Yeah, so that's an important caveat to keep in mind, is that power works against you in these models. It could be that it's not worse and that these constraints are really okay, or it could be that we lack the power to detect the difference. So if you want to demonstrate complete invariance on a scale, get as few people as possible to test that with. How's that? Problem solved. Everything's the same. I have no power to detect differences. Caveats. So this one, non-invariance in a pattern. Yeah, go ahead. I'm being facetious.
The point of invariance is to not detect the difference?
Yes. Yeah, you're hoping for the null. In invariance testing, you are rooting for the null. If you want your scale to work the same across groups, it's like, no, 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 no. And if you don't have enough people in your group, then you're not going to reject the null. You're going to do not reject the null. It's going to be the same. That's what I'm trying to say. Not the same is what I have here, though. So how would you describe this pattern using sort of regular words? The loading for item 1 at time 1 is 3.2, whereas it is a constrained 2.6 at the other occasions. What does that tell us?
The effect is stronger than that?
Yeah,
Like
say it louder.
the effect is stronger at time 1?
Yeah, the effect of what is stronger?
The effect of time on answering?
Close. We got an answer that item 1 is more related to the factor at time 1. Yeah. Yeah, the effect of the factor is how I would say that, because that's the predictor that's creating the slope here. So yeah, item 1 is more related to the factor at time 1 than the other occasions. That's what it looks like. What is item 1? Social competence. So we can make up a reason for that if you'd like. I have a reason. Are we at that one? Yeah, we're at this one. Let me zoom back out. So here's some more stuff I didn't tell you about these data that I let slide so that this person could graduate. Do you know who answered these questions? It's not the clients. It's not the patients. It's people that take care of them. Do you think there's a one-to-one match of caretaker and patient in these facilities? No, not unless you go to the really, really good expensive ones. Maybe you might get your own like caretaker, but no. So there are common people. Let's go with caregivers that are answering these questions for more than one patient. Does that sound familiar? Like patients are nested in caretakers. At the very least, you might expect if I filled out the same questionnaire for multiple people, the responses are correlated because I filled it out, and it's about how I perceive social competence and personal neatness and whatever. So this person is making perceptions about this client, this patient, who was literally just admitted. So my guess, this is me just armchair psychology here, my guess is that when you don't know someone, like how they are, like if they look like they're with it, they look like they're paying attention, you can hold a conversation, you don't have any other data to go on. That's probably going to be more important. Whereas after they've been here for 6 months or a year, maybe you know more about them, and that sort of superficial evaluation is less useful. How's that? That sound plausible? Yeah. That's the thing about social sciences. We're very good at making up reasons for findings after the fact if we need to. But that's my reasoning. All right, let's keep moving. Scalar invariance. So I'm using the tournament rule here. Because the loading for item 1 at time 1 wanted to be different, I am kicking it out of the scalar competition. It could be different simply because the loading's different, which would create a different intercept, because non-parallel lines are going to cross. So note the pattern of how I wrote the code to do this. I have each of these intercepts listed in their brackets with stars to indicate that they're being estimated, and then I put a semicolon here. From M+'s perspective, that separates that statement from what follows, as if it's on its own line. And then what follows has the constraint label before the next semicolon. So what it's doing is only those two get the I1 label. The first one is left out because it has a separate semicolon that's shutting it off. And because I am a fan of personal neatness in my code, I did all the spacing to keep everything aligned. It'll make your life easier if you do that so you can troubleshoot your errors much more easily. So we are constraining all of the intercepts to be the same across time. And then what are we releasing so that we can do that? What goes with intercept constraints? What do we got to free? Factor means. All of them? Yeah, just 2 and 3. So factor means time 1 is still fixed to 0 for identification, but because the item intercepts are now linked together with these invariance constraints, you can estimate the factor means at 2 and 3. And this is where things fell apart. So is it worse? Decidedly. All right, let's go figure out why. Paying attention to just the intercepts. Variable 5 at time 1 wants to be lower in its intercept than at the other times. Okay, I'll do that. So now we're at scalar B. These are my naming conventions. I use a number for the layer of invariance, and then I use letters for like how many iterations we're in. So I think we're going to end up at scalar E in this model. Like there's going to be that many that we have to free. I was helping a student with a project once where in her code, it was like, this is scalar X. And I'm like, oh my God, is that how far you had to go down to get, it's like, just no. If you're at scalar X, you just need to X on out of that and be like, nope, I'm out. It's not invariant. Can't make it work. Scalar X is never a good sign. So this is the point where I'm like, yeah, even my eyes are bleeding. I'm just going to throw them a bone. Here's what I fixed. So I separated item 5's intercept at time 1 from the constraint. Survey says, am I headed in the right direction? Yes, I am. It's better than the previous model, but is it still worse than the loading partial metric model? Unfortunately, yes. So now we go over here, and it's variable 4 at time 1 that wants its intercept free. Okay. Do that one. Now I'm at scalar C. Still headed in the right direction, but are we there yet? I don't know, 0.05. So I headed on over, okay, what's left? Variable 2 at time 1. Okay, 3D, added that one. So I'm adding notes as comments as to at what point they were released so that I can add that information to my write-up. Seems like time 1 is going to be a problem. Yeah, time 1 is starting to fall apart relative to the rest, how these items behave at the other occasions. So here's where we're at with respect to fit. RMSEA continues to be not great. CFI and TLI are also sort of mediocre. SRMR is mediocre. Are we still headed in the right direction? Yes. Are we there yet? Thank goodness. So yeah, we're at 3D. So here's the end result of the intercepts. So only item 3 and item 6 have invariant intercepts over time. The others, time 1 wants to be different from, for 1, 2, 4, and 5. And they're different in different directions. So when you are telling the story about invariance, it's not just they're not invariant at the end. They want to be different. Different how? Well, in terms of intercepts, it looks like for item 1, there is a lower expected response at the same level of this latent trait for that item at 1 relative to 2 and 3. So for whatever reason, people are lower in social competence than they are later. Oh, I know, maybe it's because treatment works. Maybe that's one of the goals of treatment, is to make them more competent. Same thing with item 2. They are less something, social something was what it was, at time 1 relative to the others. 3 is okay. Now 4 and 5 have a different pattern. They're more of 4 and 5 at time 1. And then 6 is okay. So if you want to talk about change over time in this trait, it's going to become increasingly difficult to do so without adding a bunch of caveats. The more of these you have to let go. Change between time 1 and time 2 is now only a function of item 3 and 6. Because that's the only case in which the 1 is linked to 2 and 3. However, change between 2 and 3 is indicated by all the items. So these are the things you would want to be transparent about as we go down this road of things falling apart. Error variance and variance is the last step. I did the same pattern of constraining what I could, only the ones that were kicked out of the tournament already. Why does this say 4A for everything? That's another typo. I mean, go back and fix that. Oh, no, it does. I know. It's not a typo. I'm right. It's because these are the constraints that I could not have because they already lost out of the tournament. Survey says, yeah, it fit worse. Okay, modification indices, variances and residual variances. Item 5 at time 2 and 3 is listed in 2 places. So it wants to be different than item 1 in both respects. So we can do that. 4B is the next model. Release those constraints. Check the fit. Headed in the right direction. Not there yet. Modification indices say, okay, item 6 at time 1. All right, we'll try that one. Next. Release that constraint, check the fit. Headed in the right direction, and we are there yet. And here's what the error variances look like. So note this is not a parallel items model. We are allowing different amounts of error variance across indicators. The constraints are within an indicator over time. And it looks like in particular the oddball is item 2 at time 1 has a lot more not the factor variance to it. Have a comment, so many models, yeah. So does this check the p-value, change the model, check the p-value, change the model, check the p-value, change the model thing sound like good science to you? Might someone have a problem with that? I wouldn't call it p-hacking per se, because we're doing repeated tests to try to get to a null result. But if it makes you uncomfortable to rely on all of these, what I used to call cheat codes, to make all of these changes, yes. Unfortunately, there's not necessarily a single right way to go through this process. Like if you start in one place and like a different decision could turn you down a different path in terms of where you would end up. So there is a whole literature on this and the use of modification indices on this. This is at least one easy way that you can try to troubleshoot misfit. But if you're at the point where you're having to release like a lot of things, then that should make you uncomfortable, and you would add to your limitation. You know, this is a very data-driven. We would have to, you know, have repeated replications to see if these patterns hold in multiple samples, all that kind of thing. So yes, these are caveats. And none of this, by the way, we have not used the word effect size once in this entire week, right? Because not the same. Someone might want to know how much not the same, right? Is it like completely different? Like in this picture, where did it go? I lost it. Hang on, let me get to a picture. The egregious one. Partial, there it is. Here's a good example. I would be very concerned, right, about a gap this big. I would be not as much concerned about a gap this big. So if any of you are looking for psychometric research ideas, the idea of how to evaluate effect size as part of this, I think would be a good topic. I put in a link to one article that I've seen on it, but I haven't seen a lot of work about it. So how to use not just statistical significance testing of various kinds, but also try and take into account effect size and indices of that in this context, I think is important. By the way, there are alternative ways of going through this process that you may see in the literature where people say, well, if my CFI doesn't change by 0.01, then I'm good. Yeah, no, that is not going to hold for every situation, because all of these fit measures have situations in which they would be biased high or low as a function of characteristics like reliability, model size, sample size, and all that kind of stuff. So it's not great to do all the models and all the significance tests, but there's not necessarily great alternatives that would work all the time. So trying to be honest with you about that. Okay, so we're not going to get to structural and variance today, but that's what's coming next, with a crossover tie-in to the longitudinal class for the fall. Because remember, the whole point of this was to do a growth model at the end of this. So we will see in the next class whether that is going to be logically possible. Because you know what has to happen to fit a growth model? Things got to grow. That's a prerequisite. All right, questions as we wrap up the week? No? All right, then let me know if you need anything. Have good weekends. Work on your homework 3 revisions, and I will see you next week. Bye for now. Thanks for being here.